facts and figures of Postgres and how do we implement some of the important components in the Postgres. Have decades of Postgres experience, right? Which is a pretty rich experience that we can leverage on, right? So ask any questions, ask, be interactive. We would like all the sessions to be as interactive as possible. Okay? And the talk is about some of the known facts about Postgres and some of the nuances that Postgres has been following for a very, very long time, right? And then there's a very important component and a topic to have. And thanks to Vinay and Sashi for taking time and coming and presenting here. Yeah. Over to you.
Thank you, Hari. Thanks for giving us the opportunity to come and interact with you all. So we are pretty much excited to do this. So yeah. So today we are going to discuss about important considerations while working with Postgres databases, right? Okay. So before jumping into the topic, I just like to set a context, right, so that you will understand. So yeah. So for example, when you are working with Postgres database, means there will be two scenarios, right? So either you are developing an application from the scratch using a Postgres database, right? That would be one scenario, right? And the other would be when we are planning to migrate from other databases to the Postgres. For example, migrating from an enterprise database called Oracle, right? From Oracle to Postgres. So when you are migrating from Oracle to Postgres, so there are so many challenges and so many things we need to consider, right? So today we are going to discuss more about from the migration point of view, and we'll discuss more about the Postgres, what are the challenges, or what are the things we need to consider while working with Postgres database. Okay, so yeah, I'd just like to start with this agenda. So first of all, we try to give the high level overview about the database migration. So why these database migrations are happening, what is the main reason. Okay, so and we'll try to give you the overview about what are the benefits are by migrating into the database. Okay, then next we'll try to discuss more about the migration life cycle. Okay. So in the migration life cycle, so what actually happens from the in the complete life cycle of the migration, from the starting from the assessment until it goes to the production. So we'll try to discuss each and every topic in detail so that you will understand, right? So once this migration cycle is done, then we are going to cover one of the important topic choosing the right data type in Postgres. Yeah. As you all know, so when working with the databases, data types are the one of the crucial things which we need to wisely take a decisions, otherwise we are going to face some challenges. So we'll try to discuss we'll show you with examples what are the implications you may going to face, right? Okay. Yeah. So the next we'll try to we'll discuss more about avoiding exceptions without breaking the functionality. Right, as most of them are the database developer here, I think. So we all know, right? So when working with the databases or the code objects, when procedures, functions, right? So we generally use the exceptions, right? So we know it's a costly operation in Postgres. So we'll discuss how we can avoid this one and with more in detail with examples. Okay. The next we'll try to we'll discuss about the volatility classification in Postgres. Okay. Yeah. Next. So first, just to start with the database migration overview, as we all know that nowadays the companies are migrating from the commercial database engines to open source databases, right? Because of the many reasons. For example, there could be the cost savings, right? So migrating into the open source database, you are going to get a better cost savings, right? While working on the migrations, there could be so many reasons because of that the customers choose for migration, right? So there could be the cost savings. While migrating from enterprises database to open source databases, we can consider the cost saving will be the one of the important factor, right? So the next would be like the vendor independence. So when most of the customers are like try to come out of the vendor dependency, right? So they just want to be independent while working with the database. They want to choose their own the plans for the support and all, right? This could be one of the reason, right? And there could be other reason like the compatible standards, right? The better compatible standards, and there could be the improved performance scalability, or there could be active community support. So when they are then planning to choose for the open source database, they generally prefer for the active community, as we all know. So among all the open source databases, if you see the Postgres is widely preferred as a powerful database because of their so many reasons. But I can say like there would be the robust feature, reliability, and extensive functionalities, and the better performance also, right? So this is a high level, the complete migration life cycle. So generally when working on the migration project, so there will be so many the phases in the migration, right? When we, for example, with the start with the application, right? First of all, the choosing the proper application which can be migrated is a very much important factor. So because some applications are tightly coupled with their database which cannot be migrated. The first most important point would be the choosing the proper database which can be migrated to the open source database, right? So that will be the first step, and once we're done with that, then we'll come into the migration assessment. So this is the important factor in the migration. So in the migration assessment, we'll try to understand like how much complexity it could be, and how much effort is required for migrating the entire database, how much resource is going to be required. So everything we'll try to cover in the migration assessment. Once we're done with this migration assessment, we'll be having an idea like how much the planning and everything, right? So that how much time it's going to take for the database to be migrated to the open source. So now we have chosen the database and we're done with the assessment. So the next important step will come under for the migration is the schema and code conversion, right? So this is an important point in the migration, like the converting the code objects and the schema objects are very much important. So in this, while working on the schema and code conversion option, we will be having so many different objects, like there could be the data type mapping, the converting of all the tables, constraints, indexes, these all come under schema objects. And then when we need to work on the converting the code objects, right? So the code object means like the procedures, functions, triggers, everything will come under the code object. We'll try to take care of all this in the schema conversion phase, right? So we are going to discuss more about this one in the upcoming slides. Okay. So then now we have chosen the database and we are done with the assessment. We have converted the code, right? So then we need to work on the database migration. So the data migration, while working on the data migration, we'll be having so many the different tools, right, in the market. Maybe we can use the Nora to PG, right? So we're done with the data migration. So we'll be using a tool to do the data migration and the validation. Once the validation and it's done, the next step in the migration will be the testing. As we all know, the testing is the important in every step of the conversion. So there could be different types of testing we will be conducting. So one could be like the sanity testing, or we can say like it's a kind of a unit testing or the basic level of testing. This can be done at the time of the development, or at once the entire conversion is completed, we can do the sanity testing also. And there could be, we will conduct like a functional testing, integration testing, and so many different kinds of testing will be done. Once the testing is completed, then before going to the production, so generally the customer, for example, he came from the Oracle background, right? Before going to you don't know exactly how it's going to behave. So when working on this kind of migration project, generally we will try to conduct some training session to the customers. So this could be like a workshops, or like we try to cover all the topics related to the Postgres, so that they'll get a confidence. Then once the trainings and everything is done, then we'll plan for the production database migration. So once the production is completed, then we'll plan for the once the application everything is completed to the production database, then again it's not going to be ended, right? So after the many scenarios where once the migration is completed, and we may going to have some performance issues. So this could be an opportunity where we need to work on the tuning of the queries, or like the stored blocks, whatever is making the issues. So So once the tuning is completed again, and once after the migration is completed, we generally suggest the customer to do the regular health checks on the database what is migrated, right? So in the health checks, I think generally you might be knowing, like we'll be for that maybe the tables which is going to happen, the blots, or can be the vacuums are not working properly. So everything will be taken care in the health check operation. Right. So there are so many different phases, right? So we are, as per the time consuming, we try to discuss more about the schema and code conversion today, right? So when working with the schema and code conversion, so generally we will try to take care of four more major things, right? So in that, first one will be the data type mapping, then the schema conversion, then we'll work on the code conversion and the sanity testing. Okay. So in the data type mapping, so this is the one of the important step we need to take care while working on the database migration. So otherwise we'll going to face so many challenges. We'll try to discuss more about this data type mapping in the upcoming slides. Okay. So in the schema conversion phase, so we'll try to migrate all the tables, constraints, indexes, everything will be taken care in the schema conversion part. Okay. Once the schema is converted, again we'll work on the converting the procedures, triggers, and everything. Then everything is done, then we'll work on the sanity testing. Okay. But coming to Postgres, it's completely different, right? We'll be having so many different options. So choosing the proper data type is very much important. Okay. So for example, if you have a decimal data, right, so then you should go for double precision or a numeric data type. Right, if you have a non-decimal data, either you should choose integer, big int, or the small int based on the usage. So we'll try to discuss like how we can generally choose the proper data type while migrating the application. Okay, so yeah, so this is the general guidelines when we generally follow while working with the migrations and while choosing the proper data type, right? So for example, if you have a table and I have a column called ID, right? So and having the scale is 0, that means that I don't have any decimal data, right? But the precision is less than 5, right? In this scenario, we should go for the small int. Right? If we have in the precision is more than 5 and it's coming before the 9, below the 9, and the scale is 0, then in this scenario, we generally suggest to go for integer data type. So in the same way, the precision and the scale is in between 18, then you should go select the big int data type. And if you have the double precision, for example, the precision and scale together, like the decimal data and non-decimal data together completely, if it is 15, then only you should go with the double precision. So there could be some challenges while using the double precision. So I'll show you with the example like what could be the issues, like if you choose the double precision if it is not appropriate. Okay. So and anyhow, if you since we have seen in the before slide, right? So the maximum size of the big int is 18. So before it is going beyond that, then we have only option to go with numeric. Okay. So actually we have, if you want to dive deep into this one, like how to choose the proper data type, we have the reference link here. We discussed it detailedly, like how to choose the proper data type. Okay. So yeah. So when working on the conversion, so I have not planned. I did an analysis and I used a wrong data type. Okay, so we'll try to see like what are the implications we are going to face while choosing a wrong data type in Postgres. Okay, so there could be like a storage inefficiency as we have seen in the before slide, right? For example, if you are going with the double precision, the default size is 8 bits. Okay, so but the small int is only 2 bits of size. Okay, in source we need to analyze the data, right? So for example, the source, the data is only under small int, right? So if you're choosing a double precision, the size of database is going to become more, right? So generally what we do, we try to analyze the source data and we're going to prepare the entire report and we'll share the customer to, so this is how we are planning to suggest the data types. Okay, so based on, again, that's not going to be the final final version of the database, we can say, because again those can be changing. For example, I have a employee ID column in my table, right? So the employee ID, as per by looking at the data, I can say like it's under only big integer data type. So you can go with integer, but the customer or the DBS having the proper idea that in future it may go beyond the integer also. So it can be better fixed by big int. That's why once we get the approval from the customer, we'll apply for the actual data types. Okay, and one issue will be the storage efficiency, right? In second, then we can see that could be the data accuracy and the precision issues, right? As was just now we were discussing about the double precision, like what could be the data accuracy issues. We'll discuss in the next slide, like how the data is going to be when we use the double precision, how the data is going to be failed, right? So, and the next would be the performance issues, and whenever we work on this calculating the mathematical calculation of data, so going with the, for example, double precision, you may going to face some performance issues, or even if you choose the numeric also, there would be performance issues. So we need to choose properly which data type is. Okay. So we'll show with an example like what can be issues. So just to illustrate, I just created one small table with the example. I'm using the data type with the double precision here. Okay. So now I'm trying to insert this data, this kind of data. Right. So from the application, I have not chosen like what was the data in my source. I just randomly selected double precision and created a table. Okay. So when I insert this data, so what happens is the data is going to be truncated, and the main important point to notice here is when the data is going to inserted here, you are not going to get any exceptions or anything, right? So then you are going to face so many challenges here. So many of the applications or financial applications, that each and every decimal value is also be very important. So we need to be choose wisely. In this scenario, so this created the same table by using the numeric here. Okay. So when I insert the same data here, now the data is not truncated, right? For this scenario, numeric is a proper choice. So we should not use double precision in this scenario, right? So yeah, this is one example. So for example, we'll see the next example, right? So what I did, I created the small table, okay. So and I created with using the numeric as a data type, okay. So and I created the index as well on the particular table. For example, if you see the table have 4 columns: ID, name, values, and txdt, okay. And I created an index on the values column, okay. Now this table I have inserted in 1 million data. Okay. When I query this some data from using this values column, you can see it's going to take 2.51 milliseconds. Okay. So now whenever we having this kind of the calculations or mathematical, right, we should not use the numeric data. So just I created the same table now with using the big int now. Okay. So I created the same index here. Okay. So now if you select the data from this table, you can see the execution time is almost reduced by 50%, right? Now you can see like almost 2x performance difference is here. So if I choose numeric in this kind of scenario, you can go to face the performance issues. This is a simple example, but when you work on a real-time project, you can see so many issues while using the numeric data type. Okay. So taking the proper decision before only it's going to help us. Otherwise, we need to do so much of rework and all. Okay. So to conclude this, we generally from the past experience, we generally this kind of best practice we can suggest. So while working on the table which is having some calculations, right? So in that kind of scenario, you should not use numeric there, okay? Because better than numeric, integer or you should go for big int. So this will give you the better performance compared to numeric, okay? So in the same way, for example, if you don't have any decimal data, unknowingly you should not create any numeric data type in that kind of scenario. Okay. So and in the same scenario, when there is a non-numeric data, non-decimal data, then you should go for either small int, integer, or big int by checking what is the specified length which is having in the source data type. Right. So in the same way, if you are having any arbitrary precision, then you have to choose for numeric only. Right. So as of now, we have discussed about the migration cycle, and we have chosen the data type database, and we started converting the schema. Right, the schema conversion is done, and now we have completed the data type mapping also. We have created the tables also. Right. So now the tables and everything is created. Now the next step in our migration will be working on the code objects. So the code object means we need to work on the objects like procedures, functions, triggers, and all, right? So as we know, when we are working with this kind of these objects, generally we come across the exceptions, right? as we all know, the exceptions is very costly operation in Postgres. So we need to be wisely choose, and we try to avoid these exceptions. So Shashikanta is going to cover like about these exceptions. Over to you. So before jumping,
where there is a database,
okay,
a Oracle database,
right,
which is having like 500,000 lines of code,
correct,
right, and non-functional objects and everything, right?
right,
If I have to convert that to Postgres,
correct,
and if I have to estimate it and estimate the steps and create a flow of it,
yeah.
what would be the approach?
So, or maybe we can use an Oracle PG also. It's going to analyze each and every database object. For example, how many database objects are present, how many procedures are present. So how much code can be automatically converted, and how much code it's not able to convert automatically. We need to do some manual code conversion, right? So based on that, we are going to estimate the effort, like how much effort is required to complete the code, and how many database developers are required, right? So based on that, we'll plan the entire migration. Yeah. So maybe, for example, database, like what are the crucial object which cannot be converted directly, where we need to do some manual conversions, right? Those things.
Okay, so it was related to performance.
Right.
The question is like when you were trying to gauge whether the Oracle, the way it was being performed,
yeah,
and the performance of that, when you were moving it to Postgres,
okay,
whether it's going to retain the same level of performance, is it going to take the same functionalities that you used to have? Of course, not everything is movable, right?
right,
If we try to gauge the nearest possible performance,
yeah.
what would be your approach to gauge it? Like, how do you calculate the best to mimic a Oracle?
So, because just we need to running a procedure or a function or a SQL query, we need to understand like what the volume of data, and we need to fix the code. Like maybe that's again it's a huge topic. Like by working on the performance tuning, maybe some indexes are required. Like everything, we need to do deep dive into the performance issue, because the performance will not be common only on the database level. There could be many other factors, right? So we need to understand like what are the what were the implications, like why this performance issue is coming. So after doing the deep dive, then we'll get to know if it is the really the issue from the code object. When we'll try to analyze the code, and we can tune the query.
So what's the best practice at the architecture level? Because once I have already done this, right?
Right.
So that Postgres thing is almost 70 or 80% done.
Correct.
Now I'm getting performance issues.
Mm-hmm.
From the project management standpoint, I do not have the way to retrace my step back and recreate it to get the proper performance. So what steps should I take at the beginning to assess performance?
So Badger report. So with that report, we'll get to know like what are the queries, the top queries which are making these performance issues. With that report, we'll get to know only the issues from where the issue is coming. Then we try to fix that issue.
Yeah, basically it depends on the target size that you are defining based on the source size, right? So you will be say for example you are migrating from Oracle, right? So you will be looking for AWS report and then various other metrics, right? So based on that you can design the target database size, and then you can configure your parameters, and then you have to again migrate the code properly, right? So simple example as we see here, right? Doing the data type mapping correctly for the tables, then migrating objects correctly. So by those you can you can ensure that your code or the database perform well when you migrate.
So you are saying to benchmark to design the database. So
yeah, so basically it'll be I have to take, right? So you have to look for the repos, right? What is the source size, or what exactly is running on the source side, right? What are the different applications are connecting, or what is the workload in the source side, source database. So based on those, you can define your target database. Thank you.
Running super fast, and when you migrate, it is performing terribly in Postgres actually. It is fine because the optimizer is quite different, and that's the reason what we say here is you need to probably mentally be ready to rewrite the whole thing. I mean, that's what we have seen most of the customers really ending up and getting frustrated. Hey, this query was running very super fine. Now I'm seeing the performance is just not at all acceptable. So these are some of the pitfalls we have seen with the customers, so that you don't really end up in an issue in later part of the stage, but early in the game you really identify those issues. And the data types is one of the very, I would say, fundamental issues what we have seen for the performance part actually. So I think we need to really educate the customers or your end users, saying that, okay, these are some of things you need to really do at the assessment phase and not during the testing phase, because that by the time you are losing a lot of amount of efforts and money in the game, right? Yeah.
We saw that if we are not choosing the data type correctly, then we run into several issues, right, including the storage issues or performance issues. So then coming to the code area that we focus while doing a code migration, right? So when we talk about exceptions, let's first understand what exceptions are, right? So when we write a code, a stored proc in a database, right? So we may encounter some errors, right? And those errors can be categorized into two types. One is a compilation errors and another is a runtime errors, right? And then compilation errors can be again categorized into two types, which is a syntax error or a semantics error, right? So syntax errors are simple, right? If we are not writing the syntax, then we'll run into syntax errors. And semantics errors are something when we are referring to some of the database object which does not exist in the database, then we'll run into that type of error. So we say that, okay, when we encounter any type of compilation error, then we have to correct that. We never say that, okay, we have to handle that, right? We go and then modify the code part there. And then there is another kind of error which is kind of a behavioral thing, right? When we write a code, we execute it, and then that error could be there, but we may not encounter. For example, we are trying to divide two numbers, right? A divided by B. And if you are giving proper value, you will not get an error, right? But if you are giving the denominator as 0, then you will encounter a 0, right? 0 divide. So that is called a runtime error. So runtime errors are something which may not encounter unless we run into that situation. So those runtime errors are called exceptions, and exceptions are always handled. We never say that, okay, we will we modify the code and then do that. So we have to handle those. And then how do we handle that in databases? We define the exception block, and then we write the logic into there, right? So we will see different use cases for exception, right? Why database developers use exceptions. So basically in the code, right, and they write the exception and then they do nothing, right? They just write trap the exception, and then they suppress the exception there, right? They do not want to throw it to the application or throw into the calling block. The second scenario I can say is that you trap the exception, right? You got the exception and then you just log into a logging table. And the third scenario could be you got exception, you handle it properly, you call some of the functions, or you do all those business logic in that. So after knowing these use cases, let's see how Postgres handles those things, right? And why we should be worried on these exceptions, right? So in Oracle, exceptions is not a problem. Oracle is very intelligent in handling exceptions. We never run into issues with Oracle database. But in PostgreSQL, exceptions are handled as part of a sub-transaction. So you define a block, and then you define the exception block, then internally it behaves like a two transaction. So that's the reason, when there is an exception in the block, then everything gets rolled back, right? Because it is a sub-transaction. So because it is a sub-transaction, you will be running into performance issues as well, right? And it is also not advisable to write code block with exceptions in PostgreSQL. So let's see what AWS document also says. So in the document also you can see that exception says that you don't use that unless it is really required, right? If there is a provision to avoid the exception, or if you can refactor the code, then you can do that. Next slide. Yeah, so I have taken a simple example. So what I have done is that I have created a function which is taking the employee ID, and based on the employee ID, it gets the employee name, full name. And if the employee ID does not exist, it gives a exception, and it's just something like, it assigns the employee name as full, not found, right? Let's see how we can rewrite this code so that we can avoid this exception here, right? Not all the exception blocks can be avoided, but yeah, there are situations where we can avoid that. So I have taken this simple example, and then what I have done is that I have refactored this code. I have removed that exception block completely, and then I have used this if not condition, and then rewritten the same logic, right, without affecting the entire functionality. Whatever the exception block is doing, that can be done through this if and else condition. And one more thing is that the strict, right, I have also removed in the block. The reason because PostgreSQL by default does not raise a no data found exception, which is in Oracle it does. If there is no data, Oracle throws an error, but exception, PostgreSQL doesn't throw the exception. That's the reason I removed that, and then you get the converted code there. So that's some of the example where you can do that. There are a lot many examples, but yeah, because of the time limit, I have taken out this simple example. Coming to the next one is again another important factor that we really look into while we are doing a code conversion, and this is on the volatility classification. So PostgreSQL, so this volatility classification you will not get in Oracle. You get that in Postgres, and then what Postgres provides is 3 different types of volatile classification. One is volatile, another is stable, another is immutable. So what volatile is that you write a code and then you are doing some kind of business logic. You are trying to do some DML operation in that, or you try to do some DDL operation in that. That means you are trying to modify the database state, right? So in that case, you define the function as volatile. And stable is something you have only select statements within that, right? So select statement doesn't modify the database state. So those functions you can change that to stable. No need to make those as volatile functions. And immutable is again another classification where you get good performance, and then that you can consider when you are doing some kind of calculations, right? And you get very good results when you use them correctly. And immutable is something like the performance you will get very substantial improvement into your database queries or in the functions. So here I have taken an example, right, the volatile versus immutable, if you see. So what I have done is that I have created a very simple function. What it does is that it loops through 10,000 times, and then it creates an array. So that means it doesn't matter how many number of times you call this function, it will always return the same array. So when we execute this function, it got executed in 13,000 milliseconds. That means 13 seconds it took, right? And then the function is defined as volatile. The next is what I have done is that the same function, because it is not changing the database state, I have converted this function to immutable. So this function is now converted to immutable, and if you execute this function, you will see the very good performance improvement. Now see, from 13,000 you get the function same calling function to 25 milliseconds, right? So this is what the difference when you use the classification correctly, right? And 500x times got increased, or more than that, yeah. Now let's see, right? Now we saw that okay, immutable is something which is giving a very good performance. So now is it can it be harmful, right? If we directly change all the functions to immutable, right? Can it harm our database performance? So looking into that, right, I have taken again another small example. What it does is that it takes a date as input, and then it converts that to character using the toChar function, and then it converts to integer, right? And then this function, right, it is a simple statement, right? And then the language what I have specified here is PL/PG/SQL. So this doesn't need a PL/PG/SQL. So what I have done is that to optimize that, I have made that to a SQL function. right? And then the next is that, again, as I said, that we can change the immutable or the stable classification, right? I have created another 2 different functions, one with stable, the same functionality, but stable function, another to a immutable, right? And then when we test it, right? So let's test these 2 now, and then see if we are having some kind of an improvement or any impact to that, right? So what I've done is that I have executed this test on a Postgres 14 version, and then I have first executed the immutable function, and you see that it took around 43 millisecond, right? Now next is the stable function. I have executed the stable function, and then now it got improved to 10 milliseconds, right? So 4x improvement that you got. So that is where, like, if you do not use the classification correctly, then your performance may be bad, right? So and then let's understand why it happened, right? Previously it have a very good improvement, but now immutable has a poor performance, right? So let's understand the reason for that, right? So in the function, what I have used is that the function has tochar, right, which is a catalog function, PG catalog function. And then if you go and check the PG catalog function definition there, it is defined as stable, right? So the calling function, it is stable, and in the outer function you are defining as immutable. That is where there is a mismatch, and then you get a very a poor performance. So we have to see that underlying functions are all immutable or not, then only go for immutable. Same for stable also. Then what are the takeaways? As I told now, when we are trying to write a new code into Postgres, we have to see that all the underlying functions should be immutable for the outer functions to be immutable. If not, then the performance will not get. Same thing for stable. When we are trying to decide on stable, then any calling function should not be volatile. It should be either stable or immutable. So with that, yeah, next. So I maybe initially we planned to cover some more topics, but because of the time constraint, we are planning to take this topic in our next meetup. So one is on the sanity testing, and then the other is on the PLPG SQL check. Next, yeah. So I think that's all. Thank you. Any questions?